Out there in the vast darkness of space, the James Webb Space Telescope has been looking into the smallest details for answers about the universe. NASA's new eye in the sky has captured astonishing images of massive stars, planets, and other celestial bodies. Then, something happens. Something startling has been discovered, so enormous that it could shake the very foundations of what we know. Researchers are now pondering their options, wondering if this discovery could provide insight into the most distant reaches of existence. Join us as we investigate the latest findings from the James Webb Space Telescope. Our understanding of the universe could be shattered as we explore the universe's outer limits. When we talk about the known universe, we refer to the visible universe, a window that allows us to examine what lies beyond. It encompasses everything we can currently see, measure, and study with our telescopes. Space is filled with stars, planetary systems, and great cosmic bodies that are within our reach. However, the visible universe is just a small portion of the entire cosmos. Think of it as a slice of a vast pie. The actual size and state of the entire universe remain a mystery. According to researchers, the observable universe spans approximately 93 billion light-years. To put that into perspective, a light-year is the distance light travels in 1 year, around 5.88 trillion miles, 9.46 trillion kilometers. When we speak of the observable universe being 93 billion light-years across, we are talking about an incomprehensibly vast distance. The universe began 13.8 billion years ago in an event known as the Big Bang. Since that enormous birth, the universe has been expanding rapidly. Mysterious forces, like dark energy, appear to be accelerating this expansion, pushing the universe's outer limits even farther apart. As the universe expanded, matter began to form. Gravity influenced the merging of particles, leading to the formation of stars, massive galaxies, and eventually planets, including our own Earth. These enormous cosmic structures serve as the framework for the ever-changing, peculiar phenomena found throughout the universe. Despite its vast size, the universe is surprisingly empty. If our entire solar system were reduced to the size of a quarter, the closest star would still be roughly the width of 2 soccer fields away. This vast emptiness continues to expand within the Milky Way galaxy, which itself is just one of billions within the observable universe. This gives us a sense of the immense scale of space. You might wonder why we can't simply observe everything that exists in the universe. The fundamental limitation is light, still the fastest thing ever created. Light takes time to travel through space. This means that when we look at distant objects, we are essentially looking into the past. The farther an object is, the longer its light has taken to reach us. In this way, the universe acts like a giant time machine, allowing us to witness cosmic history unfolding before us. When we observe galaxies millions or even billions of light-years away, we are seeing them as they were in the distant past. Meanwhile, the universe is expanding. Imagine the outer surface of an inflating balloon. Just as points on the balloon's surface move farther apart as it expands, galaxies in the universe are also drifting apart. This expansion causes distant light to undergo a shift known as redshift. As objects move away, their light stretches into longer wavelengths, making them appear redder. Given these properties of light, motion, and cosmic expansion, we understand that much of the universe remains unseen. Even with our most advanced telescopes, we are still limited by these fundamental characteristics of space and time. The question of whether the universe has a boundary or an edge has intrigued scientists and philosophers for centuries. While there are no definitive answers, 3 major theories have emerged, each offering a unique perspective on the expansion of the cosmos. 1. The infinite universe hypothesis. This theory suggests that space is infinite, meaning the universe continues to expand forever without a defined edge. It aligns with the cosmological principle, which states that the universe appears uniform and consistent in all directions. If this is true, then the universe has no limits, it just keeps growing indefinitely. 2. The curved universe hypothesis. This theory proposes that even if the universe is finite, it may not have a distinct boundary. Instead, space could be curved, much like the surface of the Earth. If this were the case, traveling in any direction for long enough would eventually bring you back to your starting point, just as one would if they traveled around the Earth. 3. The multiverse hypothesis. This concept suggests that our universe is just one of many. Some scientists propose the existence of an infinite number of parallel universes, each with its own physical laws and characteristics. These universes might be entirely separate from one another, or they could be interconnected through complex systems, forming a vast and intricate multiverse. The James Webb Space Telescope, JWST, is a beacon of potential, shedding light on the universe's deepest mysteries. This groundbreaking instrument has unparalleled capabilities, allowing us to see farther into the past than ever before. The JWST is a technological marvel, designed specifically to peer into the cosmos with unprecedented precision. A recent report published in the prestigious journal Nature revealed an astonishing discovery: 6 enormous galaxies that existed between 500 and 700 million years after the Big Bang. This means they formed over 13 billion years ago, challenging our current understanding of galaxy formation. These ancient galaxies are far larger than scientists initially expected, contradicting the prevailing theories that galaxies evolve slowly over time. The universe is truly extraordinary. Each new discovery deepens our understanding, while also raising new questions. The vastness of space, the mysteries of its expansion, and the possibility of a multiverse continue to captivate the minds of scientists and explorers alike. With the James Webb Space Telescope pushing the boundaries of what we can see and comprehend, the journey to understanding the universe has only just begun. As the James Webb Space Telescope continues its mission, astronomers eagerly anticipate the next wave of discoveries. What other cosmic secrets might be hidden in the distant reaches of space? Could we find evidence of the first stars ever formed, long before galaxies took shape? Or perhaps we might detect signs of life on an exoplanet orbiting a distant sun. One of the telescope's primary objectives is to study exoplanets, planets beyond our solar system. By analyzing the light passing through their atmospheres, scientists can determine their chemical composition. This could reveal the presence of water vapor, methane, carbon dioxide, or even oxygen, key ingredients that might indicate habitability. Some researchers believe that within the next few decades, we may find compelling evidence that life exists beyond Earth. Yet, even as we make incredible strides in understanding the universe, we are reminded of how little we truly know. Dark matter and dark energy, which together make up about 95% of the universe, remain among the greatest mysteries in physics. We cannot see or directly detect dark matter, yet its gravitational influence shapes the formation of galaxies. Dark energy, on the other hand, appears to be driving the accelerated expansion of the universe, defying our current understanding of cosmic forces. The more we learn, the more questions arise. Could there be undiscovered forces at work, shaping the universe in ways we have yet to comprehend? Are there other dimensions beyond the 3 spatial dimensions we experience? If the multiverse theory holds true, could there be other versions of reality, each with its own set of physical laws? These questions fuel our curiosity and drive us forward. The James Webb Space Telescope is just the beginning. Future missions, such as the proposed next-generation telescopes and space observatories, will build on its discoveries, peering even deeper into the unknown. Humanity stands at the edge of a new era in space exploration. As technology advances, we may one day send spacecraft beyond our solar system, exploring distant star systems firsthand. The dream of interstellar travel, once confined to science fiction, is now a topic of serious scientific discussion. Whether through robotic probes or, one day, human explorers, our journey into the cosmos is only just beginning. As we look to the stars, we are reminded of the words of the famed astronomer Carl Sagan. Somewhere, something incredible is waiting to be known. And with every new discovery, we come one step closer to unlocking the greatest mysteries of the universe. The degree of complexity is comparable to our own. The Milky Way galaxy is a 13-billion-year-old structure, with the sheer number of stars contained within it dwarfing our expectations. Given that each galaxy has a mass per unit volume several times greater than our Sun, some may even have multiple times its mass. A striking example of these galaxies is our own. The unmatched capability of the Milky Way to look into the dark corners of the universe relies on the utilization of infrared light, an invisible spectrum to the naked eye. This telescope is made possible by surprising power, allowing it to record the tiniest emissions from revealing galaxies and ancient stars, enormous traces that have remained for billions of years. Essentially, the James Webb Space Telescope, JWST, acts as a time machine, helping us see back through the centuries and providing an enthralling look into the universe as it was about 13.5 billion years ago. Previously, the ongoing discovery of massive galaxies, nicknamed universe breakers, has altered our comprehension of cosmic evolution. It's like rewriting history in an unexpected way, introducing a twist that challenges many of the models we had planned for the earliest galaxies. At first, we thought galaxies formed from humble beginnings, small collections of stars and dust that changed slowly over time, growing bigger and more complex. However, the universe breakers have shattered these notions. When the initial data and high-resolution images were analyzed, they revealed that these massive structures were enormous, as if they had just appeared out of nowhere. Going deeper, researchers employed spectroscopic methods to analyze light at various frequencies. This analysis is the key to unlocking crucial information regarding these baffling galaxies, such as the size of their structures and their distance from Earth. It is comparable to a vast investigative narrative, with light serving as the key to deciphering the secrets of these enormous entities. The extraordinary lessons learned from the James Webb Space Telescope have altered our comprehension of the universe to unprecedented heights. This cutting-edge telescope, run by an international group of space scientists, has recently made an amazing discovery: the identification of the most ancient and distant galaxies ever observed. We are transported back in time to an era when the universe was only a small fraction of its current age. The James Webb Space Telescope, floating in the pitch-black expanse of space, has been searching for answers. It is NASA's most powerful instrument for studying the cosmos, capturing breathtaking images of planets, galaxies, and stars. Recently, it made a discovery so astounding that it could redefine our understanding of the very foundation of the universe. Scientists are now perplexed and curious about the true implications of its findings. The visible universe serves as our starting point, a window looking out into the infinite beyond. Everything we currently observe with space probes and telescopes, including galaxies, stars, and other celestial bodies, represents only a small fraction of the entire cosmos. According to scientists, the observable universe spans approximately 93 billion light-years. A light-year is the distance light travels in a year, approximately 588 trillion miles, making the universe's scale nearly incomprehensible. The universe began 13.8 billion years ago with the Big Bang, a massive explosion that set off the great expansion of space. Since then, the cosmos has been rapidly evolving, driven by enigmatic forces such as dark energy. Under the influence of gravity, matter began to coalesce, forming stars, galaxies, and ultimately planets like Earth. This vast cosmic process has shaped the universe, allowing us to glimpse only a fraction of its infinite complexity. Despite its immense scale, much of the universe remains dark and empty. Even with the James Webb Space Telescope's power, vast regions remain inaccessible. However, its discoveries continue to reshape our perception, providing an inside look at the unimaginable marvels just beyond our reach. The infinity of space continues to awe and inspire us. With each groundbreaking observation, we slowly piece together a more intricate understanding of the universe's past and future. The James Webb Space Telescope is a tool that has the potential to revolutionize how we perceive space, time, and the very essence of our existence. Beyond its initial discoveries, new observations could challenge the very foundations of modern cosmology. If these enormous galaxies existed so early in the universe's history, they force us to re-evaluate current models of galaxy formation. For years, scientists believed that galaxies grew slowly, beginning as small, dense clusters of gas and dust that expanded over billions of years. However, these massive galaxies, forming just 100 million years after the Big Bang, present an unresolved mystery. Given the traditionally slow pace of development, this revelation raises new questions about the actual nature of galaxy formation. How did galaxies grow to be so large and complex so quickly after the universe's creation? What factors were at play during those early epochs that allowed for such rapid star formation and structural development? These questions not only test our current knowledge of the early universe but also challenge our understanding of fundamental physics, particularly regarding the nature of dark matter and dark energy in the infancy of the cosmos. The discovery of these ancient, massive galaxies forces scientists to reconsider the timeline of cosmic evolution. If galaxies this large and complex existed so soon after the Big Bang, it suggests that star formation and structural development occurred at an unprecedented rate, one that contradicts prior models. This challenges not only our understanding of galaxy formation but also the fundamental forces shaping the universe. One possibility is that early galaxies formed under different conditions than those seen today. Perhaps the density of matter in the young universe was higher than expected, accelerating gravitational collapse and star formation. Alternatively, unknown mechanisms, such as interactions with dark matter or unexpected properties of primordial gas clouds, may have contributed to their rapid growth. To unravel these mysteries, astronomers are turning to advanced tools like spectroscopic analysis, which allows them to break down the light from distant galaxies and determine their composition, motion, and distance. The James Webb Space Telescope's infrared capabilities are particularly vital, as they enable scientists to peer through cosmic dust and observe some of the earliest structures in the universe. These new findings also raise questions about the role of dark matter and dark energy in shaping the cosmos. Dark matter, an invisible substance that makes up most of the universe's mass, is thought to play a crucial role in galaxy formation by providing the gravitational scaffolding for ordinary matter to accumulate. If galaxies formed much faster than anticipated, it may indicate that dark matter behaves differently than current theories predict. Similarly, dark energy, the mysterious force driving the accelerated expansion of the universe, could be influencing the growth of galaxies in ways yet to be understood. If early galaxies were more massive than expected, it may suggest that dark energy's effects were already significant in the first few 100 million years after the Big Bang, reshaping the large-scale structure of the cosmos. As astronomers continue to analyze new data from the James Webb Space Telescope, they are also comparing these discoveries with existing cosmological simulations. If current models cannot account for the size and complexity of these early galaxies, it may signal the need for a major revision of our understanding of cosmic evolution. Beyond reshaping our knowledge of the distant past, these findings have profound implications for our understanding of the present universe. By studying how the first galaxies formed and evolved, scientists can gain insights into the fundamental laws governing matter, energy, and gravity. These revelations could lead to groundbreaking advances in astrophysics, potentially uncovering new forces or interactions that have remained hidden until now. The James Webb Space Telescope has already transformed our understanding of the cosmos, and its journey is just beginning. As it continues to capture breathtaking images and collect unprecedented data, the mysteries of the universe will slowly unravel. Each discovery brings us closer to answering some of the deepest questions. How did the universe begin? What forces shaped its evolution? And what unseen wonders still await us beyond the edge of the observable cosmos? The quest for knowledge is endless, and with each new revelation, humanity takes another step toward understanding the vast and mysterious universe we call home.